Hi everyone. We're going to take a look at a lesson on differentiability, and sometimes I kind of glaze right by the title of the lesson and don't really talk about what that word means, but differentiation, if you haven't heard that word yet, is the process of finding a derivative, okay? So when I say we're going to differentiate this function, it means we're finding a derivative of the function. So differentiability is referring to the ability to find a derivative. Okay, can we find a derivative at any point on this graph? So that's the main question of the day, is this function differentiable? And if not, why? So just a quick reminder here for you before we jump into these existence criteria. And this is going to be kind of the big deal in this lesson. But derivatives are found by taking a limit of a slope function. So we have two things we have to think about is how do we find slope and how do we find limits, okay? And so we have to remember, when does a limit exist? Well, a limit only exists if the left-handed side equals the right-handed side, okay? And so when we get down here into our differentiability and we're talking about this, just keep in mind that we're talking about limits, and we already know how to work with limits. So the first issue we're going to encounter is continuity, and you are already really good at continuity. If a graph is not continuous, if there's a break in the graph, if there's a discontinuity of any kind, you cannot take a derivative at that point where there's a discontinuity, okay? And that's really obvious to spot. This one is sometimes a little bit harder, and I'm going to show you in the pictures here what this looks like. But you need the left-handed limit to equal the right-handed limit, not of the function, but of the slopes. Okay, so you're looking at what are the slopes doing as you're approaching from the left and approaching from the right. This is essentially saying the derivative of the left side has to equal the derivative on the right side, coming from the right, okay? And then also, since we're dealing with slopes, we know there's sometimes that slopes just don't exist. When you have vertical lines, right? Those slopes are undefined. And so if you end up with a tangent line that is vertical, even if your function is continuous, even if it's nice and smooth and this is working like it's supposed to, if you end up with a place where the tangent line is vertical, then there's no derivative because there's no slope, okay? So now let's look at what all three of those things look like in these examples down here. We're going to look at these pictures and then we're going to talk about the different criteria. I might zoom this out for you just a little bit. Maybe not. Okay, so with that first function, the place we run into issues are there's a break in the graph, right? This thing is not continuous. So right here, and realistically everything in between, I can't take derivatives at any of those places. If I said take the derivative at 0, or if I said take the derivative at 2 or 1, I guess it would be, that's not going to work for me, okay? So these are the places where this thing is not continuous, and the issue is number 1 from the list up here, okay? The function is not continuous. Okay, this one here, though, is continuous, okay? This one's plenty continuous, and so let's talk about what's happening here. If I were to look at, well, I guess let me give away the ending. This is the place where we're going to have an issue with finding a derivative, okay? And I want you to think about this. If we're looking at these tangent lines, we have a line here, and we have a line here, and we have a line here. These are gradually becoming, they're all negative, right? And they're becoming more steep to the point where, I might have to shrink this up, but like right down here by the axis, you're like practically vertical, right? So those are like really low negative numbers. This might be a -10 or a -20 or something like that. And then you hit this point, and all of a sudden the other half of this thing looks like a parabola, and so all of a sudden you're starting over at 0 and then growing, okay? So these slopes are doing different things as we come in from the left and come in from the right, and it forms this like sharp corner, okay? And that's when this is a problem. So you're continuous, we hit number 1, but number 2 is a problem because the derivative coming in from the left is supposed to be like a really high negative number, and the derivative coming in from the right is approaching 0. This is like flattening out, okay? So the issue here is number 2 the left-handed limit does not equal the right-handed limit of the derivative. And I keep saying that because the function itself would be fine. Both functions are approaching 0. But when I'm looking at the slopes here, this slope is not approaching 0 coming in from the left. Okay? And so that's what these are always going to look like. When your limits do not match, you're going to end up with some sort of sharp corner. Okay? And this should also make sense to you, because if you were to try to draw a tangent line right here, I mean, there's lots of ways you could do it. You could kind of come down like this. You could go flat. You could come this way. When you have those sharp corners, there's not a unique tangent line, and that's the problem we're having. Okay, this third one is nice and smooth. It's continuous. There's no sharp corners. All of my limits match up. But the issue with this one is that right at 0, if I was to try to draw a tangent line, it would be a vertical line. This one has a vertical tangent. So at 0, this thing is not differentiable because of issue number 3. The slope is undefined. Okay. And then the last one we're looking at is this absolute value one. And I actually think this is almost a better example of this problem. Hopefully you can look at this and know that 0 is going to be the issue for differentiability. I can't take a derivative at 0. And here's why. If I were to pick a point anywhere over here, pick this point, pick this point, pick this point, and I say take the derivative, you're going to tell me that that derivative is equal to -1, because this segment of the graph all has a slope of -1. If I were to do this side and pick this point or this point or this point, any of them, any of the points along this line, and find a slope, you would tell me this slope is +1. And so coming in from the right, my slopes are all 1. Coming in from the left, my slopes are all -1. And then you hit this 0 point, and it changes from one to the other without any sort of like smooth transition. Okay, so this is, again, the issue is number 2. The left-handed limit does not match the right-handed limit. And that's because, again, you've got that sharp corner there that's not allowing the slopes to like naturally transition. I do want to point something out here, though, real quick on this graph. If I were to graph the derivative of this function, the derivative here, this is decreasing, so we know it's going to be negative, right? And it's constantly -1. It's -1 everywhere. So it lives down here at -1 from here all the way to 0. And at 0, it doesn't exist. Okay, so this is going to be -1 forever to the left. Okay, and then all of a sudden at 0, we've got everything equaling -1. But again, we can't take a derivative at 0. So then it would go like this. And so that function right there, that is the derivative of the absolute value function. And I took the time to point that out because you've seen this function a lot. We've drawn this many, many times. And I wanted you to see that this is the absolute value of x over x. Okay? And I wanted to draw that because I wanted you to see that this thing is what the derivative of the absolute value function looks like. That's why it's significant. Okay, we've played with this one before. Okay. I'm probably going to have to do a second video for the second part of this lesson, which covers how to find derivatives on your calculator. That will be a very handy tool for you, but this will get you through at least being able to figure out when and where things are continuous. I'm sorry, when and where things are differentiable.